Welcome to another new video of interesting math problem on our channel Math Solutions for You. Please do like, share, comment, and don't forget to subscribe to our channel. Which of the following cannot be a possible value of radius of a circle whose center is at origin and has the straight line x minus 2y equal to 5 as one of its chords? And we're given three values which are kind of close: 2.1, 2.2, 2.3, and then we have to select from options A through E one that's correct, meaning that there may be one or more than one of those values that are given in 1, 2, and 3 which may not be or which cannot be a possible value of the radius of the circle. So this is a coordinate geometry problem, and what I prefer to do here is, though it's not really necessary in order to solve the problem, it's always helpful to draw out this in the coordinate system and trying to make a little bit of sense of what the problem is about. So I start with this drawing the coordinate axes. We have the x-axis, the y-axis, and where they meet is basically the origin 0, 0, right? And then we are trying to draw this line x minus 2y equal to 5. And the easiest way to draw any line is basically find the x and the y-intercept. For the x-intercept, we just put y equal to 0 in the equation of the straight line, and we solve for x, in this case x equal to 5. So that would be the x-intercept, which is 5, 0, the coordinates of that point where this line meets the x-axis. And similarly for the y-intercept, we put x equal to 0 in the equation of the line, and we end up with y equal to minus 5 by 2. So that's the y-intercept, and that occurs at this point 0 minus 5 by 2. And then if we just join these 2 points, we get the equation of the straight line, or we get the straight line whose equation is provided, which is x minus 2y equal to 5. Now, what does it look like for a circle whose center is at the origin and which has this straight line as one of its chords? So we can just draw a circle with center at origin like this one, and you can see that the circle meets this straight line at 2 points. So definitely this straight line is a chord of this circle. But this is not the only circle that we can draw. In fact, we can draw many circles. We can draw a circle with an even bigger radius, and that still has got the straight line as one of its chords. However, we can note from this figure that if we draw a circle whose radius is small, it still has its center in the origin, but the radius is quite small, it may not actually, the circle may not actually intersect this line, x minus 2y equal to 5. And that circle will not have the straight line as one of its chords. So seems like from what we have so far that there is a limit to how small the radius of the circle can be, because if it's smaller than a certain limit, then this line that we have in orange, which is our given line x minus 2y equal to 5, would not be a chord of that circle. So with that understanding, we can now proceed to solve the problem. And the way I'll do this is, I simply have a circle. I'll assume that the straight line is one of its chords, and the circle of course has its center at the origin, and I'll take its radius as r. And it will be helpful to recollect here a quick lesson from coordinate geometry, which basically states that equation of a circle with center at origin 0, 0 and radius r is simply x squared plus y squared equal to r squared. So that's basically the equation of the circle that we have drawn out in green. And let's suppose that the coordinates at the point of intersection of the chord x minus 2y equal to 5 with this circle is AB, A comma B. So A is the x coordinate and y is the y coordinate, and then B is the y coordinate. And therefore, this point of intersection with coordinates AB will satisfy the equation of the circle as well as the equation of the chord, right? Because it's a common point belonging to both the circle and the chord. So we can write this: a square plus b square is equal to r square, and a minus 2b is equal to 5. So from the second equation, a minus 2b equal to 5, we can express a in terms of b as a equal to 2b plus 5, and then we substitute this in the other equation, a square plus b square equal to r square. So we substitute a equal to 2b plus 5, and this is what we get: r square is equal to 2b plus 5 whole square plus b square. And then if we expand 2b plus 5 whole square, we get this: 4b square plus 20b plus 25 plus b square, which comes to 5b square plus 20b plus 25. Now, if we take 5 as common from the first two terms, so we get this: 5 within parentheses, we have b square plus 4b, and then we of course have 25. Now here what we're going to do is what's called completing a square. And for this, we'll basically focus on the terms within the parentheses, and we will see what is it that we need to add to those terms so that within parentheses we have a complete square. And in this case, it's actually very simple. If we add 4 within the parentheses, then we have b square plus 4b plus 4, and that becomes b plus 2 whole square, right? So we have a square within the parentheses. However, since we added 4 within the parentheses, we have to, subtract something so that we maintain parity. And what's that something? Well, we have added 4 within parentheses, but outside the parentheses we have 5. So we have actually, in effect, added 20. So we need to subtract 20 in order to maintain parity. And then we can write this: 5 multiplied by b plus 2 whole square, and then outside parentheses I had 25, but now I also subtract 20, so that becomes 5. So I have 5b plus 2 whole square plus 5. Now, b plus 2 whole square, at the least it can be 0. It's a positive term in general, right? But it cannot be any less than 0 because it's a square, right? It has to be 0 or positive. So that means that r square has to be greater than equal to 5. And if r square is greater than equal to 5, we know that r being the radius is a positive quantity, so r has to be greater than root 5. And root 5, its decimal approximation is 2.23. So we know that r has to be greater than equal to 2.23. So if we look at the options that were given in terms of possible values, we have 2.1, which is clearly not permissible because r has to be greater than 2.23. But also 2.2, that's also not a permissible value of r because r has to be greater than equal to root 5, and root 5 is 2.23, so it's greater than 2.2, right? So r has to be greater than 2.2. But 2.3 may be a permissible value for r. So going through all the options from A through E, the correct choice seems to be option C, 1 and 2. So those cannot be possible values of the radius of the circle. And the value in 1 is 2.1. The value given in 2 is 2.2. So these are the options, 2.1 and 2.2, that cannot be possible value of the radius of the circle.